take the product, enthalpy, or the heat, subtract what we started with. And so where did this energy come from? This is the enthalpy change. So first of all, let me define this very strange word, enthalpy. Basically, it means heat. And what we're concerned about is not just the heat, but the change in heat. So remember, the change is that delta sign. So delta H is the change in enthalpy. In other words, it's the heat change associated with a reaction. So here's a little reaction. We've got little sparklers. This reaction actually produces quite a bit of heat. And so in a reaction, heat is either absorbed or emitted. So enthalpy is just that term representing heat content. Now, remember, the enthalpy change is the important part, and here's what you need to know. For a reaction, it is the change in heat. In other words, the final, which is your products, minus initial. Okay, so we're going to take the product, enthalpy, or the heat, subtract what we started with, and get the change in enthalpy. So let me show you on a diagram. This one makes a little bit more sense. So we're going to start off with our reactants. I'm going to put that down here. And our reactants have an enthalpy of 80. And then when we're done, our products are up here, and they have an enthalpy of 160. So the enthalpy change for this reaction would be the enthalpy of the products, which was 160, minus the enthalpy of the reactants, which was 80. And so our change in enthalpy is going to be a positive 80, and our unit is kilojoules. It's positive, okay? So we start off with a low enthalpy, and at the end of the reaction, we had a high enthalpy. So where did this energy come from? This is the enthalpy change. We absorbed heat, right? We went from low to a higher enthalpy, and our delta H is positive, and we call this endothermic. Endo means in, and so we have heat going into the reaction. So we got a positive delta H. Now, one thing I'll mention real quick is this big bump right here. This amount of energy is what we call activation energy, and that will be important in the future. So it takes a lot of energy to get this thing going, and then we get a little bit of that back. Now let's go on to exothermic reactions. What do you think exo means? It means out. The heat is going to go out. So let's look at this one. We start off with our reactants. Our enthalpy is about 400. And then our products end up way down here. We're at about 200. Okay, so let's do our calculation for the change in enthalpy. The products was 200. The reactants 400, and that's going to be equal to negative 200 kilojoules. So our enthalpy change is this difference right here. So where did all of that energy go? We started out with a lot, and we ended up with a little. All of that energy right here, that 200 kilojoules, went out into the surroundings. So that reaction produced a bunch of heat. Be familiar with those energy diagrams, what an exothermic looks like and an endothermic.